Well, good evening, everyone. We are on our last section. All we have to do is homework 22, and we'll have finished everything for the final. And it's basically, we're going to look at word stories applications. So before we get into looking at some of these word puzzles, imagine I had a sketch of a quadratic, say something like this. This particular quadratic is going to be, I don't know, minus x squared plus 4x plus 10. Right. Now, what the quadratic equation is telling me is that for any given value of x, the y-coordinate on the curve would be found by doing this calculation. And you can imagine I could find various points on this curve if I was wanting to be really accurate, right? And I could plot lots of them and do a sketch, but that's not what we're after. In this last one, we tend to be after two specific places on the curve. A lot of the application questions that you're going to be solving want you to find the coordinates of the vertex. So the top of the hill or the bottom of the valley. And occasionally, not so often, they also want you to find that guy there. Can you remember what name we give to the place where a quadratic cuts and touches the x-axis?
The x-intercept?
The x-intercept. So imagine this curve had a story attached to it. We're not going to get into the details of what the story might be. I could simply just ask you to tell me the x and the y coordinate of the vertex. Now, there is a formula for getting the coordinates, the x coordinates of a vertex. It's that guy, right? Now, for this quadratic up here, the a is -1 and the b is 4. Now, I don't care that the c is 10, so I'm not going to use it. So I won't even bother writing it down. So the x coordinate of this vertex is -4 over 2 times 1, which is 2. And we get 2. So that guy there has an x coordinate of 2. Now, how do you think I'm going to find the y coordinate of this vertex? I found the x coordinate is 2, but how am I going to get the y coordinate? Everything that I need to do that is in front of you somewhere. So what do you think I use to get the y coordinate?
The original quadratic?
Yeah, this guy. Exactly. So I'm going to take this fella and I'm going to find out what it's equal to when x is 2. So it's going to be -2 squared plus 4 lots of 2 plus 10. I'm going to show you a problem that you might do if you're not careful. Right, so hopefully you can see this calculator. This is not brackets -2 close brackets squared. That is not what this is. It's 2 squared and then you find it's negative. So you type this in, it's -2 squared plus 4 times 2 plus 10. And that gets you the correct answer. That's 14. That's the correct way of doing it. The wrong way of doing it would be to put a bracket around it and call it -2 brackets squared. Add 4 times 2, add 10. Now I'll get an answer, but it's not the correct one. So will you make sure that when you do these quadratics, that you're just a little bit careful about what does the 2, in this case, the 2 mean? It just means that this x gets replaced by 2. It's a little thing, but you know, it's the little things that then I won't actually even do the wrong answer in case you see it. So this guy here is 14. Now I'd like to find this x-intercept. Now x-intercepts are when, in this case, the parabola hits the x-axis. If you want to find an x-intercept, you solve when is y 0. In other words, you have to solve a quadratic equation. Can you just trust me that this one doesn't factor? I wish it would. Because it doesn't factor, I'm going to have to do the quadratic formula. And for the application questions that we are going to do in these questions, but for the application questions, it's okay. Oh, poor Lexi can't get through. It's okay to have decimals when you're finished. In fact, you're just as likely to get a decimal as not. So let's see what that ends up being. I find this fella first. So that's 4 squared. Take away 4 times -1 times 10. That's 16. Add 40. That is 56. And then use the quadratic formula, which is this ugly guy. And that's going to be the negative of him, so it's -4, plus or minus that fella, over 2 times this one, which is -2. And that gives us 2 possible answers. -4, add the square root of 56 over -2, or -4, oops, take away the square root of 56 over -2. And at this point here, I'm just going to make sure that my calculator does all the hard work. So put a bracket around it, go -4, add the square root of 56, close the brackets, divided by -2, and I get the answer, let's say to 2 decimal places, -1.74. And if I do the one over here, I get a bracket around it, -4, take away the square root of 56, divided by -2. In this case, I get 5.74. So do you see that you just actually get decimal answers? And for the application questions, that's kind of what you expect to do, right? So don't be surprised. But only one of these answers is actually this guy. Which one of these 2 x's is actually this one here? That number or that?
5.74.
I like your answer. Yes. Why is it not this one? There must be a reason. You look at my picture, why does this one make sense, but that negative 1.74 doesn't make sense?
Because the other one's negative.
Right, so it'd be over here where my finger is, right? And, you know, negative times don't make sense anyway at the best of time, right? So we have found the vertex. It was nice numbers. And we found the x-intercept, which was a very ugly number. So what's an application question going to look like? Well, I'm going to use this question again. I'm just going to turn it around a little bit, I guess. I'm going to do. So there's going to be a building in my story. This is in fact question 1. And in this building, you're told that this distance from here to here is, say, 10 meters. And that there's a guy on the top and he throws a ball and it looks like that. At last, I think I'm getting Lexi in. Now Rachel's not coming in, darn it. Okay, now in this story, the height of the ball at time t is given by that equation. Now, if you look at this equation and that equation, do you notice that the only real difference is that these are called x and y and this is called t and h? Okay. So your variables might change names, but really, isn't this guy like your y coordinate? That would represent the vertical height that the ball is in. And this guy here, lots of them, but this one here, that would be like your x. So would that. And then they ask you questions like this. What's the maximum height the ball reaches? So this is the question. What is the maximum height? And what we have to understand is that what they're asking you for is basically that distance there, right? But isn't that distance there really the y coordinate of the vertex? So we've already done that. Now the formula is x equals minus b over ta, but can't you just change that thing and say t equals minus b over 2a, and you will get the exact same answer. And instead of saying y equals this, you can then replace it by h equals this. But when you do that, you still get the answer 14. So this distance from here to here is 14 meters. And that's what you put in to your WebAssign box. So they're not going to say, find the coordinates of the vertex. They're not even going to say, find the y coordinate of the vertex. What they're going to say instead is, maybe in this case at least, what's the highest height the ball gets? They could have asked, how many seconds does it take for the ball to reach its highest height? In that case, wouldn't the answer be 2 seconds? How many seconds before the ball reaches its highest height? Answer, 2 seconds. What's the highest that the ball reaches? Answer, 14. Do you see, they're just disguised questions asking you for the x and the y coordinate of the vertex. Only they're not called x and y anymore. They're called t and h, but that's just a label, right? And then they had the second question. The ball returns to the earth after how many seconds? That's the ball returning to earth here. Isn't that a disguised version of this? So the time the ball takes to reach earth is 5.74 seconds. So you're going to get questions where a story is attached to the shape, or the story, or there's a formula attached to the thing. Any questions about that first one? Are you good? Okay. I think that's a nod. Oh. The next question. The cost, see, in dollars of operating a certain concrete cutting machine is related to the number of minutes n the machine is run, and this is the function. So the cost to run for n minutes is 1.6 n squared, take away 48 n, add 615. So if you run it for 4 minutes, you put n equals 4 and into this formula, and that's how much in dollars it costs to run the machine. And here is your question then. For what number of minutes is the cost of running the machine a minimal? So,
Is that a C parentheses N or A?
that's an n.
Okay.
So it says here, find the number of minutes where the cost, just paraphrasing it, where the cost of running the machine is a minimum. If I said to you, what does this shape look like? Don't need to be too detailed, but if I asked you to type, have a little look at this guy and try and imagine what its shape is, would you agree it would probably look like a happy face? I'm making no attempt to be accurate, but how do I know that this is a happy face shape? There is a clue in the formula. How do I know that this thing, and this would be n and this would be cost, is going to be a concave up happy face shape?
Because the first number is positive.
Right. Now, it's a downright ugly number, so don't expect, 3s and 2s in these questions, right? They're a little bit more realistic. So when it says find the number of minutes where the cost of running the machine is a minimum, aren't they asking me to find that number here? What would be called the x coordinate of the vertex. Do you see they're just wanting the vertex again? These questions very often end up being find the vertex, or at least one of the two numbers that make up the vertex. Based on this equation, won't A be 1.6 and B be negative 48? So normally the formula would be x equals negative b over 2a, where this guy would be the x and this guy would be the y. It's now going to be n, right, equals negative b over 2a. The negative of negative 48 is 48, divided by 2 lots of this, which is 3.2. And then I go to my calculator and I do 48 divided by 3.2, and I get 15. So we've just answered our first question. Find the number of minutes where the cost of running the machine is the minimum. The answer is 15 minutes. Now, the second thing that they asked us here is, what is this minimum cost? So I know that if I run this machine for 15 minutes, that's the least it'll cost me, right? It's the cheapest I can get it for. What will I do to find what the minimum cost is? I know it takes 15 minutes, but what can I now do to find the second part of the question? There's a little clue. Can you see the cost? Would be what would be, well, I guess you'd call it the y coordinate. How do I find the minimum cost? Another chance. Minimum cost at 15. Okay, here goes. There's the cost function. And you know that at 15 minutes, it's going to be the smallest it's ever going to be, the lowest, if you like that word instead. Here we go. 1.6 times 15 squared. Take away 48 times 15 plus 615. And the answer I get is 255. So I'll assume it's dollars. And that would be our second answer. So question 2 was Zuli, find the coordinates of the vertex. All you had to realize is that the x coordinate, the 15, was the number of minutes where the cost is a minimum, and that the y coordinate, right here, is essentially the same time. That's how much it cost when it was 15 minutes.
Do you not do anything with the other side, the 15 on the other side?
The 15 on the other side. This here? Is that what you're talking about, Vanessa?
Yeah.
That's just the function evaluated at 15. That's just a notation that you use to say that's the number I'm going to use here.
Oh, okay.
I could have just called that C, and it wouldn't have made really any difference.
Okay.
And how did you get the 3 with the 2a? 3 times 2?
Oh, that's 3.2, and I got that by 2 lots of 1.6.
Oh, yeah, I see. Okay.
My decimal point is moving. No, that's the right place. Isn't that where America's put your decimal point?
You put it more in the lower, like where the blue line is, but then I forgot there's a 0.6 with the squared on top.
Okay. So right. So it's 2 lots of 1.6. Are we good with that question now that we've done it? We only have 6 questions, so we're 1/3 of the way through. You get your own version of this question, of course, but the way won't change, the method won't change. Are we good with these 2? Right. Side note, I am now going to show you a cool piece of software that I have put onto your canvas shell, so you can use it if you choose to. It's going to take me a few moments to find out where it is. Right, here it is. I'm going to stop sharing for a second. And this is some software that allows us to sketch quadratic. Well, actually sketch anything you like. Let me make it a little bit bigger. Can you see this guy called Desmos at the bottom? It's a new guy. Now, I'll click on Desmos. And this, basically, it's like a graph appears and a little box in the left-hand side. So, the guy that we just did, since he's the one that's in front of me, I'm going to go C equals, and I'm going to type in 1.6 n squared. Now, if you want to get squared, you can hit this little thing down here, and you can hit that button, n squared. Then I'm going to go take away 48n, and then I'm going to add 615. And then I'll click out of this. And where are you? Oh, so. It should take this. I tried this and it was, oh, I know. Okay, no biggie. There we go. There. That is weird. I was using this. There we are. It's working. What the heck have I done a few seconds ago? Okay, so y equals 1.6 x squared. There. Working away fine now. 48x plus 615. Oh, that's what's happened. It was always there. It was just up here somewhere funny. Right. Okay, now I got it. C equals that guy. Just playing about with this for a few moments. That guy. Now, this, if I shrink it really back, is not a very easy to see quadratic. But I'll show you how you fix it. It looks like this. If you click on the little tool, you can tell it to change the x values to any number you like. So I'm going to change it to -20 to +20. And hopefully, hey, I'm not doing anything right today. Oh, look, I didn't change it at all. Well, I thought I changed it. There we go. Now, if I move this cell around, there, can you see it looks a little bit nicer now? Now, right there, if I click on this guy, can you see that it's 15, which is the n value, and 255 is the cost? You see that's the coordinates of the vertex. Show you another guy. If I go back here, let's kill this one off. Right. If I go back here and I type in h equals -d squared plus 14 plus 10. And then I change my window so that it's now going to go from 0 to say 6. That's good. And the Y value goes from 0 to 25. There we go. Can you see the parabola? I can move it up a little bit. Yeah. Can you see the one where it was leaving the house and it hit the ground? And if I click on that guy, can you see the coordinates of where it hits the ground? So you can actually use Desmos. You'll have to, if you want to use Desmos, you don't need to, because you have to adjust the windows all the time. It's a little bit of a guessing game. But if you use it, do you know that you can find coordinate of vertex? Just click on it, and coordinate of x-intercept. Just click on it. And if you click on it, you've got your answer. So that is a different way of solving that problem. It's kind of cool, right? A little bit different. For some people, software is second nature to them. So you might actually like using that piece of software to answer some of these questions. For others, you're just going to stick to the algebra, and that's totally fine. So I'm now going to go to our next puzzle question. This is question 3. The total number of enrollment in year X is given by 0.054 x squared. Take away 1.164 x plus 50.604. That is a quadratic. It just has really, really ugly decimal values for it. And the only question you're going to get asked here is find the lowest enrollment. This is a positive x squared. If I drew this thing, it would be a happy face. When they ask you to find the lowest enrollment, they want you to find the y coordinate of the vertex. If they wanted to know what value of x was the lowest enrollment happen, then that's what they'd have asked for. But they want that guy there.
Is that minus 1.164 or 1,164?
It's 1.164. Right, so I know how to get, and hopefully we all know how to get, the x coordinate of the vertex. In this story, A is 0.054 and B is negative 1.164. So the x coordinate is the negative of that guy, which makes it positive, divided by 2 times that guy. And I'm going to just do it in a calculator. 2 times 0.054 ends up being 0.108. And that becomes 1.164 divided by 0.108. And I get the answer 10 point, what accuracy? Oh, they want, let's do it to 2. Now that is not the answer they want. That's the x coordinate. We want to find the enrollment, right? The lowest enrollment. So what I now do to finish the question is I find the enrollment of that really ugly number. So it's 0.054 1.154 times the x value squared. Take away 1.164 times that x value. Add 50.604. If I do all of that calculation and I round it off to just one decimal place, I get the answer 44.3. The units happen to be millions. So this is the third word puzzle question we've done. And in every single one of them, we ended up finding something to do with the vertex. Either the x coordinate or the y coordinate, and sometimes both. It's not that these are any different than normal quadratics, you know, like 2x squared minus 4x kind of things. It's just that the numbers, the coefficients, are typically really ugly. And as long as you've got your calculator, you'll be fine. Here is question 4. The revenue that you get when you sell X stereos is negative x squared over 2 plus 80x, take away 1,000. I'm going to call that negative a half x squared plus 80x, take away 1,000. Now we are being asked to find the maximum revenue and how many you sell to make that revenue. Now, based on what's happened in the first 3 questions, do you realize that you're just going to find the vertex again? Now, let me try and draw this picture for you. Because this is a negative x squared, won't it be one of these kind of shapes? Right, it's a sad face because it's got negative a half x squared. This fella here is the vertex. That number there is the how many you sell. And this value along here, whatever that number happens to be, that's the revenue. So, x is negative b over 2a. In this case, a is negative a half and b is 80. So x is negative 80 over 2 times that guy, which is negative 1. Oh, there's a nice number. You sell 80, and what are you selling? Stereos. 80 stereos. And what we would call the y value, in this case it's called the r value, is negative 1/2 this guy squared plus 80 times this guy minus 1,000. And the answer that you get ends up being 7,000. You can check it, but that's what WebAssign says. So the solution to this puzzle, what's the most revenue you can make? 7,000. How many do you sell to make that happen? 80. Doesn't that just basically end up being the coordinates of the vertex? But every question we've done, as I said before, is something to do with the coordinates of the vertex. Any questions? We only got 2 of these guys to go. Last chance, any questions? Okay. Oh. I'm going to nip over and show you our last 2 questions.
Let's take a look at the process of graphing quadratic equations in 2 variables. So let's remind ourselves what we mean by a quadratic equation.
And you will watch a video and then you'll answer the question. And then you'll watch a video and answer the question. And then you'll watch a video and answer the question. So those last 3 guys, I'll let you do. But in each video, they tell you what to do, and if you just follow their instructions, and you'll have your last answers. And that is us. It should have finished. I always think when you finish a class, we should have finished with, you know, a drum roll and fireworks and whatever. Instead, we just kind of petered out, didn't we? Got some questions. Said, look, you're going to watch some videos at the end, and that's the last thing in Math 99. And it is. So what I'm going to do now is show you that I have some other things to keep us going. Our test, our final exam is a biggie. 30% of your grade is going to be based on this. So I'm not quite sure what you can see, but I'm going to zoom to where we are. Our final exam is on Wednesday. That's a week on this coming Wednesday, right? And that is going to be from 5 to 8. So you're just going to turn up like you did as always. And it's going to be on Wednesday, the 16th of June. So you all got a note of that. Make sure that you definitely make it for that day. The final exam is going to be very important because if you do really well in it, it will help you grade a lot. And if you don't do so well, then it won't. And that's not so good. So we don't want that.
You don't know how many questions there'll be there yet?
No, but I've got something to help you. Because you don't know, you've not really had many exams from me, so you don't kind of know what's happening. Are you looking at a thing that says Math 99 Practice Final Exam Solutions? Can you see that? Right. So if I, again, go into student view, it should look a little bit more the way you would see it. I have put together, we click on this, a whole load of questions that you would get similar to what you might get in your final. So you can get an idea of how I ask the questions and what kind of things, you know, you need to remember how to do. Should make this a bit bigger. Yeah. Now, I'm just scrolling through these questions. And then here are the solutions. So that basically isn't extra homework or anything. You can choose to look at that or you can choose not to, but it's up to you. But you have to, you know, you have to be prepared for the final. So whatever way works for you, but at least you'll know the kind of questions that I ask and what those questions would typically look like. Your Actually, Jamie, I was too quick when I said I don't know what questions are going to be in the test. I don't know what specific questions are going to be in test, but I do know how many, which is what you asked. There are going to be 10 multiple choice, and there are going to be 10 section 2 questions. So I'll give you an example of what each of them might look like. Where are we? When you get a multiple choice, I don't know if you've ever done multiple choice, I'm sure you have, but just in case you've not. The test is going to be the final exam, I keep calling it test. It's going to consist of 2 sections. Section 1 is multiple choice. There are going to be 10 questions. Each one of them is worth 5 points. So, take that back. Each one of these is worth 10 points. And that comes to 100 points. And then there's section 2, and that's going to consist of 10 questions as well. But they're going to be worth more, and they will add up to 200 points. So that's where your 300 points is going to come from. So, an example of multiple choice.
I have a quick question about section 2. Is that going to be
Yes.
a lot like the midterm was? Where
Yes.
basically A, B, C, D, or whatever?
Yeah, very
Okay.
much.
Okay.
So, section 1 might be something like this. So you get a question like that, and you get 5 choices typically. And I put each of the answers in here, whatever it might be. And I normally finish with some other answer as the 5th choice. And only one of these will be correct. So in this particular case, what would the correct answer look like? It looked like B on the outside to A on the inside. So that would be the correct answer. Just double checking that. Yeah, it would be B, the square root of 2A. Now the other 3 would be wrong, and they could be wrong for all sorts of different reasons. I might just simply do this as a wrong answer. Because you might just think all you do is you separate into 2 square roots and that's the end of it. I might do one where you do something like that, but you don't simplify it down. I can't think of a wrong answer for the next one, but I do something else that's wrong. So there's only 1 correct answer and 3 to 4 wrong answers, and you pick the right one. And when it's a multiple choice question, the only thing that I'm interested in is the letter of the alphabet that you believe to be the right answer. There very often will be lots of work associated with that, but I don't need to see it. Actually, I don't want to see it. Multiple choice has 1 strong point and 1 weak point. Right.
So we don't need to show our work in
I don't
multiple
need to show you
choice?
working for anything on multiple choice,
Okay.
which is a strong point because it means you can figure out the answer. If you don't know the answer, don't you guess, because you at least you might get lucky, right? That's a strong point. The weak point, yeah, don't get partial credit. So if you do 90% of it right, but don't quite do the right answer, and you do, something like that instead, you don't get anything. So when you do multiple choice, you have to be really, really careful that you do it exactly correctly, because the 3 or 4 wrong answers will be pretty good wrong answers. They will look reasonable. They might even be something that you got and because you made a particular mistake, and that's what would happen. Now, the section 2, as you were saying, is your usual questions, right? Where you're asked a question, there very often is an A, B, C to them. And I want to see the working in section 2. And the reason I want to do that is so that you can get partial credit. So if if you make a mistake or you don't do something quite perfect, but 90% of what you did was exactly what you should have done, then at least you can get 90% of the points. So for section 1, no working. For section 2, show you working. Now your exam is on Wednesday. I get the number here. 9, I believe it's the 16th of June. And it's going to be our 5 to 8. You're going to have to take a Zoom, like always, right? Like we did in the midterm.
Is that
So
the
you'll be-
16th?
I think it is 16th. Let me not quote something and tell you some date that's wrong. It is. It is Wednesday the 16th, 5 to 8 p.m. And when you're finished, you upload your working into Canvas. There is a little bit of difference here. The Canvas doesn't have, the half-hour window time, because there could easily be a lot of pages, and you might forget a page, or a page is unreadable, or something goes wrong. So you've got to have plenty of time to fix it. But you don't leave your final until I've looked at it and I've quadruple checked that everything is right and I know all your answers, and then you're done. You shouldn't need 3 hours typically. Most people finish before that, but the 3 hours is there, and then you have some time to upload it into Canvas on top of that. So time typically shouldn't be a problem if you know what you're doing. Everything in web is, yeah.
And you want us to do it like we did the old midterm with Adobe Scan, right?
Yeah, that would be the best way to do it. But some of you found other ways, and if that works for you, you can do the other ways, right? But yeah, Adobe Scan's easiest for me. What else was I going to say? Yeah.
Oh, I got
Yeah.
another question.
Go for it.
Is it going to be on all the work from start to finish, or just from
Yes,
work that
correct.
from the midterm?
All the work from start to finish,
Okay.
with probably a little bit more weighting to the second half because you've already done a midterm on the first half. So it doesn't mean you won't get questions from the first half, but it won't be like half the questions. It'll be less than that.
And it'll be about 20 questions long.
Yeah, 10 multiple choice and 10 section 2.
Okay.
Typically your multiple choice, or well, not typically, your multiple choice are 10 points each, and the other ones, they're not all going to be exactly 20 points. Some will be 15 and some will be 25, but they'll average out at 20, so you'll get 200 points. Where am I going with this brain here? WebAssign will disappear and Canvas will disappear. The only part of Canvas that won't disappear will be the PDF that has the test on it. They upload your working here, and that Desmos that I've shown you, if you want to get used to playing with it and using it, right? Those will be there. Everything else will be gone. So it's up to you what notes you've got to make your life easy, right? Are we good so far?
I have a question. Is it open book?
You can, anything new physically written down, yeah, you can look at it up. So you probably want to have good notes, because if you have to look up and find every single topic, you will run out of time, right? So if you keep handy notes, that'll make your life easier. Continue with this process. Oh, for instance, here are some strategies that I have found that help some people, most people actually. We're doing section 1. Right, that's multiple choice. If it takes you more than 5 minutes, to do the question, you're doing it wrong. So just guess, pick C, whatever's your favorite letter of the alphabet. My multiple choice questions should be able to be done in less than 5 minutes. If you think, oh yeah, I know how to do that. I'm going to, do this, and then I'm going to do that, and then I'm going to do this other thing, and I know I can do it, and it takes about a page and a half or what to do it, then that's not the right way to do it, and you're doing it wrong. And so pick C and move on. If you don't know the answer to a question, pick C or whatever you like and move on. Now, suppose later on you decide that, oh, I think I know how to do that one now. Well, you can just go back, can't you? And you can scrub out the C, and change it to D. That's easy. See, I don't see it until your final answer, right? The one that you're going to send me. So you can change your mind as many times as you like in the multiple choice. I won't see the working anyway, won't I? Just see the letter. So it won't matter to me what you did.
So
you
everything
can
will
actually
be
get-
like the last test on the Adobe Scan.
So you upload it in Adobe Scan. Now, so that's one of the advices I give to you. If it takes more than 5 minutes, you're doing it wrong, guess. And if you don't know the answer, you can guess. Staring at a question for 10 minutes just stresses you out, and you don't really very often get anything at the end of that 10 minutes. So you might as well say, it's B. Hey, maybe this is my lucky day and I'll have guessed it right, and I can say, wow. Now, in section 2, I suggest that you look over the questions first. And then do them in this order. First ones, do the ones you know first. Right, there are going to be 10 questions. You're going to scan through it and say, oh yeah, I know question 1. I could do that in my sleep. I don't like question 2. I have no idea what he's talking about in question 3, right? But I know 4, right? So you do all the ones you know first. Do next the ones you kind of know how to do. So maybe you know how to do the A part, but you're not sure how to do the B part, right? Or you know how to do 2 out of the 3, but you don't know how to do the last one, right? That kind of question. Do them next. And then C, the last thing you should do is do the rest last. Now, the reason why I'm suggesting that you do section 2 in this kind of jumbled up order is that if you do the ones you know first, psychologically, won't you be a little bit more comfortable? Because you'll say, well, there, I got 4 questions in the bank. I'm pretty sure they're right. I know I'm going to get 80 points. And then you do the ones that you kind of know next, and maybe you get 3 or 4 of them, and you can say, well, I might not have got them all right, but I definitely know I've got enough to pass this final exam, right? I've got enough points in the bank. So when you come to the last ones, right, you're not too worried anymore, I hope. You're going to say, hey, I'll have a shot. Maybe I'll figure out how to do it. I'll try something. I may get partial credit, but that's not a stress.
For
It seems, yeah.
for section 1, I know we don't have to show our work. Would you prefer if on our paper that we turn in, would you rather just see the letter choice we have and do our work on a separate page?
Perfect way to do it. So this is what I would love to see. For section 1, I just like to see That's all I need to see. Right, just one page with the letters. Right. Now, you don't need to rewrite them all the time. So I can imagine that you went back and checked it and you said, oh, no, it's not B, it's really A. That's all you need to do. That's not a biggie to me. I can tell you wanted A, right? So you can just have one page with just section 1 on it. And when I go to grade it, it's going to be easy for me, right? Now, there's a whole lot of working. You're going to do it in Pager. I don't even see that. You don't even upload that. I don't care. It's not what I need. All I need for section 1 is this. Now, when it comes to section 2, it would make my life so much easier if you did each question on a separate piece of paper. So although you'll do them in the wrong order, when you're finished, can't you put them back into the right order? So paper 1, question 1, paper 2, question 2, you see what I'm saying, like a little book. And then if you copy it in that order, it makes it easier for me to check it. So that would be my strategy if I was doing this. One page for the multiple choice, and then a separate page for each of the 10 questions in section 2 that have the working. Hopefully you don't need 2 pages, but if you did, then I guess 2 pages will do. And then when you're finished, you can put them back in order, and it'll make it easier for me to check. Any other questions?
In the next class, or the next class or 2, because the final's next week, right? Yeah.
Yes.
Will we do what we did for the midterm, and like for the class period, we just did a few, like a question from each section?
Yeah, that's
as like
probably
a-
that's my goal, but I'm pretty flexible. If on Wednesday when we come in, hopefully today before we leave, I want to get a kind of start on this as well. When after I've talked about what topics we've got, if you've got a specific topic, it would make my life a lot easier if you would say, you know, I'd like to spend some more time on solving radical equations. It didn't really make sense to me. I couldn't figure it out. Or I'd like help on this kind of question, and I will do that. But typically, if I don't get requests, I will just say, okay, these are the kind of questions, the kinds of things you need to know in this section, and so on and so forth. And I'll be doing that on Wednesday. Now, on Monday, the following week, Wednesday, I'm taking attendance. So if you're not here, you've lost a day, and you don't want to lose participation points. Monday's a little bit different. Monday, you might just want to spend that time doing your own revision, or you might want to turn up. And I'll be here anyway on Monday, but you get attendance for Monday, whether you turn up or not.
So Monday's kind of going to be like an office hours kind of.
Yeah, that's a
thing.
good way of looking at it. It's like a big officer, because you might only want to know one thing on Monday. Right, over the weekend, I found out I don't know how to do the addition method well. And so you turn up on Monday and I do 2 or 3 examples, and you'll say, yeah, I'm happy with that, bye-bye. And that's how it's going to work, right? So you don't turn up because you're fine and you're just getting ready, or you turn up just because you want to know something. You might just turn up so you can watch everybody else's questions, because that helps you too, right? And you turn up for the whole day. And it's really very flexible Monday. Whatever works best for you is what I want.
So we don't have to show up on Monday then?
If you do not want to show up on Monday, I'm going to assume that you are getting ready for that final, and that works better for you, because maybe that, you know, your time's valuable, so I want to make that time the best suit for you, right? It's pretty good. All I really want to do now is look at my notes and practice. Well, great, you do that on Monday. You don't need to be in class. Getting some good questions here.
And also, if we say on Monday I'm studying, but I need something at like 6 p.m., I would still be able to come in, even if it's late.
Yeah, I'll be here for the whole time.
Okay.
So I won't leave until what is it, 7:15 on Monday. So I'll start at, what is it, 5:30? I can never remember when this class, 7:45. It starts at 5:30, right? And we finish at 7:45. Agreed? So I'll be here to the end. So you might not even know you have a problem and then at 7 o'clock you're going to turn up and say, hey, I just found out I don't know how to do something. I'll still be here.
That's for next Monday.
That'll be next Monday, yeah.
And the practice test is already on the classroom, right?
Yep, it's ready right now. You can have a look at it and whenever. Before we do that, I'm going to move over. And where the heck is it? You can never find things when you want them. Okay, there we go. So let's give you a quick rundown of our topics, starting at the beginning. First topic that we dealt with, oh good, we're on that screen, right? Was essentially linear equations. And we did solving them. And we did graphing them. And we did applications. I guess I'll call that topic 1. So, can you remember you got things like 2x plus 3, and 3x plus 2y equals 8, and you had to draw those guys. Do you remember those questions? That would be the graphing. Solving would be a system of equations. Do you remember we did things like this guy and that guy? Well, let's ask a question. Suppose I wanted to solve this system of equations. This straight line, this is also a straight line, they're both linear. The way this one is set up, would I do the substitution method or would I do the addition method on this?
Substitution.
Okay, correct. What was the clue?
The first equation is y equals.
And wouldn't this guy basically go in there and then you solve? Now, when we do the applications, and the applications were, you know, 4 hamburgers and 3 fries cost you $10, and 2 hamburgers and 1 fry cost you $7. How much does a hamburger cost? How much does a fry cost? Remember those kind of questions where there was a story that you had to create the equation and then you solve. And that was essentially, that's a very rough idea of what the first topic was. So that was in first weeks. That was actually weeks 1 and 2. Then topic 2. And topic 2 was to do with rational expressions. Rational expressions are basically fractions, right? And the kind of things that you got to do here was you had to simplify them. You had to multiply and divide. You had to add and subtract. We had ones called complex fractions. And then we had, well, equations, solving equations. Okay, let me pick some of these questions. For instance, I asked you to do maybe a divide. It might be something like this. 3x plus 6x squared over x plus 7 divided by x squared minus 49 x plus 1. That would be an example of number 2. Now, this question could be a multiple choice question. If it was, one of the letters would be the right answer. Can you remember the process that you'd use to do this? How would you go about dividing those two fractions?
You had to flip it.
Okay. And when you do the fancy jargon for flipping it is reciprocal. So when you do the reciprocal, it looks like that. Now, where are we off to now? What's the next piece of the process? What?
You want to factor it?
You want to factor it, yes. So I was about to say, you're right, Jamila, that's exactly what you do. When you look at that practice final questions thing I've got, the top guy are all questions, and then the second half is the solutions. So one way you could use that would be to go and do a question. And if you know how to do it and you get the right answer, you can say to yourself, yeah, I'm good. I know how to do those. I don't need to worry too much about studying, right? I'm pretty good at those. And then you get a question like this and you were looking at that and you're saying, I don't remember what to do. Then that might be a good sign that you need to do some revision on multiplying and dividing rational expressions. Now, there's a different skill involved here. Now we have to remember all the different types of factoring that can happen. Right? So let's take 3x plus 6x squared. You want to factor 3x plus 6x squared. What do you get? What's the common factor?
A 3x.
When you take a 3x out, you're going to be left with a 1 plus 2x. Is x plus 7 as good as it's going to get? In other words, you can't do anything to it. X plus 7, can you factor it, or is that pretty much as good as it's going to get?
Good, that is.
A little bracket around it. 2x plus 1 is as good as it's going to get. But x squared take away 49 can be factored. What would it factor like? What could you factor x squared minus 49 with?
X plus 7 and x minus 7.
Now, if this was a section 1 question, you still have to get the answer, so you've got no points. So multiple choice are kind of dangerous. If it's a section 2 question, you're already getting points because what you've done up to here is correct. You might not have finished it, but you're getting there. Well, I factored it. What do I do now?
Then you want to cancel whatever is on the side.
Okay, who can you cancel?
X plus 7 and 2x plus 1.
And in this case, I am left with a 3x and an x minus 7. And technically, everything in the bottom has gone. So I guess technically there's a 1 there, but we don't write fractions with 1 on the bottom. So wouldn't that be the answer, maybe D, in the multiple choice question? Now, what would the other answers look like? Well, unfortunately, see this answer here? That would probably be in the multiple choice. Now, isn't it 99% right? But it's not the perfect right. So when you do multiple choice, you've got to be really careful that you're doing it correctly and make sure that the answer you pick is the ultimate best answer. Now you might think, well, I wonder what the other wrong answers would look like. Well, there's a couple of things I could do here. Maybe you forgot to turn it upside down. I could do that. Maybe you'd cancel some x's with x squares. I could do an answer that happens to. show you one last one of this type. Let's look at a complex fraction one. That's a complex fraction. Basically fractions with fractions in them. And if you want to simplify these guys, there's a very special technique. Can anybody remember what the technique we used to simplify a complex fraction?
Special
Magic version of one.
Okay, what special version of one do you want? It's the right thing to do.
2x.
Agreed? Now, if you now you got that's great. If this was section 2, you've actually got a fair number of points just for doing that, because that's a very important thing to know. So the fact that you did know that and you picked 2x would actually get you more points than you think, because that's a hard thing to produce. Now, I'm going to take each one of these 4 guys and multiply them by 2x. So if you took, well, yes, I should do them down to the side. If you took this guy and you multiply him, right? Whoops. Try again. If you take this guy and you multiply him by 2x, don't you basically just cancel out the 2's and get x squared? So this guy gets me x squared. You take the second guy and you multiply him by 2x, you cancel out the x's, in which case you get 2 times 2 is 4. 2x times 1 is the only easy one. And 2x times this guy. And you cancel out the x's and you get 6. You remember doing those guys? So solving equations, complex fractions, add and subtract, whatever it could be, right? What was I going to say there? Since there's only 20 questions, 10 multiple choice, 10 section 2, it is quite possible that every kind of question that could have, only, I don't know, half of them will ever appear. So you might be really good at doing complex fractions, and then I don't even ask you a question on it. But you know how Murphy's Law works? See the questions you don't practice and are good at, aren't they the ones that always end up in the final? Right, see the ones you're good at, they don't tend to end up in the final. That's Murphy's Law. So always work in the assumption that you need to know everything, because everything could happen. Is there anything from that list you want me to talk about before I move on? Do you want to see an example of any one of these? We'll be doing it on Wednesday as well, but just right now, if you feel like I'd like to see one just to see it. Yeah, don't hear any volunteers? Yeah, move on. Our third topic is radicals. And we are going to, you're going to simplify them. You're going to add, subtract. Multiply and divide. Special thing called rationalize the denominator. And solve equations. guess I put complex numbers here. They kind of belong in two places, but they can belong here. This stuff didn't appear in the midterm. So you're going to get more questions from this topic and the last one than you are going to get them from the first two. So the first two topics we covered in the midterm, you will get questions, but not as many. This topic and the one that comes after this, that will be, there'll be more of them in the final. Number 4. And I'll do 2 versions. Rationalize the denominator are questions where you get guys that look like this, and you want to make the bottom square root disappear. So rationalize the denominator is taking a question like this and removing the square root from the bottom. Can anybody remember the trick that you use to do that?
U times the other
So run by radical 3.
You agree, Jimmy? Is that what you're saying? Yeah. Now the top ends up being 4 root 3 and the bottom ends up being 3. So you can imagine that that question will not get you a lot of points, because this question would be like an A, B, C, D kind of question, right? It'd be a section 2. But you got a couple of points. Now, if I do this one, you end up with this answer. But that's not actually us finished. So if this question here was worth like 2 points, this question here's going to be worth 4. What have I still to do with this fella that I didn't need to do with this one?
Simplify the 2 and the 4.
And you end up with that guy. Now, if you did this answer, you'd get all 4 points. If you only got this far, you only get 2 out of the 4 points. But at least you get partial credit, right? You didn't get a big fat 0 that you would get in a multiple choice, right? In a multiple choice, it's one answer. If it ain't that one, you get 0. But then you can do the ultimate version. That would be the horrible version of that same question. What special version of 1 are we going to do to fix this guy?
Square root 2xy.
And the top becomes a rather weird looking, that guy. And the bottom goes and becomes that. Is that the best answer, or can we do better? Is that the final answer, or can we do better?
Can simplify it more.
Okay, what can you cancel? What can cancel here? Can I cancel an x? Can this x cancel out that x? Yep. And this y here cancels one of them. So what you're going to have is 3y squared with that ugly thing over a 2. And that would be, as ugly as it looks, that would be the final answer. Oh, let's just chuck in an easy one. I want to simplify the square root of a. I'll take any volunteers. Simplify the square of 80.
You can do 16 square root 5 or 16 times 5, square root 16 times 5, and then take the square root of 16.
You nailed it. That's exactly what you should do, Vanessa. Right. Now, here's a very, very similar question, but with a different answer. Cube root of 80. I think we got a lot of practice at square roots, not quite as many on cube roots. How are you
So
going
I
to
know I struggle with the cube roots with the variables that are more than
Mhm.
2.
Yes, they are troublesome, aren't they? When we come back to doing Wednesday, you will ask me or remind me, and we'll do some examples of that and work on them.
Okay.
So look at this is just numbers, so it's a little bit different. I mean, it's still cube roots, but it doesn't have the, the y squared issue. What do you get 80 to split as?
Is it 8 times 10?
It is. And then you can do the cube root of 8 times the cube root of 10. And that's a nice number. So it's 2 cube roots of 10. Now, when you're doing square roots, aren't the numbers that you're going to use come from this list? Right? But when you do cube roots, don't the numbers come from?
Yeah, I was gonna tell Rachel I have like a cheat sheet for like my test notes of like all that square root stuff where you can times 8 by 10 and figure it out.
And are they helpful, that little cheat sheet thing?
Yeah, because everything's right here.
Rachel, contact her.
I'll take
And
whatever
also-
hints I could get.
Yeah, because it's just like this, and then oh, my camera won't
Can't
show. it 'cause
see,
it-
yeah.
yeah. But it has
So
everything on
Are
it, so
you
you
a
just look
member
back.
of that group that
Hey,
Sean
Jamie
was a
Lynn.
member of?
Yeah,
Would you be able to-
I can
Oh,
take
sorry.
a screenshot of it, but my handwriting is kind of. You can. It's not that messy on this one, at least, because it's my notes. For
Could
the
you
test.
email it to me or text it to me?
Yeah, I can.
Okay.
You're not in the group chat, right?
No.
Okay.
But I'll let you two figure that out.
Send my
while we
number
move.
at the end and then you could just send it.
Okay, no problem.
Thank you.
And we're on to our last topic. And we'll go into some of these on Wednesday, the ones that you find are the most useful. And topic 4 is basically to do with quadratics. And that's the latest ones that we've done. So we're going to go through things like completing the square. Quadratic formula. Then graphing. And lastly what? Well, vertex and parabola and all that good stuff. But basically, the things I did at the start of today. Remember those questions where you get applications? I'll just call them applications. And in the applications, you're really interested in the vertex, aren't you? You know, all the application questions end up being, what's the x coordinate of the vertex or what's the y coordinate of the vertex? And that's our last topic that we are covering. So let's talk about graphing. In WebAssign, you do that little piece of software, don't you? Where you just click on 2 points and you get it. If you got a graphing question, it could be 2 different kinds. One is you actually do square paper and you find the x and the y intercepts and you find the vertex and you draw them and you draw your picture. Or if I do a question as a multiple choice, you'll get 4 pictures. I'm sure what my pictures are going to look like, right? And it'll be called A, B, C, or D. and you'll have the guy up here, whatever he might be, and you pick the right one. So your graphing questions could be multiple choice, where I give you 4 pictures and you pick the right one. Or it could be one of these where I ask you to tell me the x-intercepts, tell me the y-intercepts, tell me the coordinates of the vertex, and then I would ask you to sketch it. So it'd be like an A, B, C, D question, right? So question A would be, tell me the y-intercept. Question B would be, tell me the x-intercepts. Question C would be, tell me the coordinates of the vertex. And question D would be, now draw the graph. Imagine how that question might work. That's worth a lot more points than this. One of the reasons is, couldn't you just go into Desmos and figure out which one it looked like and pick it? And that would be a totally acceptable technique. In this one here, don't you have to show me an awful lot of math about how you got your answers? So it's a little bit different kind of question. Are we good? There's a lot of stuff we've had to take in today. I understand that. Hopefully you won't get too stressed out in the next week and a bit. Is there anything I've not covered? You've been really good at the questions, so you've kind of asked things I should have told you. Is there anything I've missed that you still don't know about? I think we should finish today at this point, and that way it'll give you a chance to just look at the stuff I've got and get ready for Wednesday. When I do see you on Wednesday, I want to make it a full day. So I want you to have every possible version of a problem question that you can come up with. But to finish with, I think I should tell you a joke.